Welcome to MongoDB TV. We're live again on Thursday. We have in the AI show. We haven't really named this show, but every Thursday we stream something AI related, usually building something, live coding. So welcome everyone. Let me know in the comments. Did you know that MongoDB was in the AI space? Yeah. So what we're going to do today is we're going to build a chatbot using MongoDB vector search. So we're gonna just get right into it. We're gonna live code, build a chatbot. I'm hoping to have some audience interaction. Let me know if you have questions along the way. I'll answer your questions, and yeah, we're just gonna build this thing. So let me share my screen. I'm gonna loosely base this off of, and I'll put a link in the chat here. We are going to loosely base this off of this workshop, Let AI Be Your Doc. So this is a self-paced workshop if you want to just do this on your own. Very, very nice resource here. So there is a, let's see, comment here. Building a RAG with Mongo in the next stage for our startup. Awesome. So well, I hope this helps you. Let me know if you have any questions along the way. Good to know. So we are going to build a chatbot that answers questions off of our custom information. So that is called RAG, Retrieval Augmented Generation. Let's go into, I'm just going to go straight up to the vector search part here of this workshop. And so MongoDB Atlas has had built-in full text search for many, many years. And we also have vector search, which is semantic search, which basically means instead of keyword search, it finds similarities between things. And that is very important in the AI space, that we find things that are related or semantically related, right? So there's an example here is if we search for how to make a cake, and we did that with a keyword search, we might not get as many results as with a semantic search, where we might return things like how to bake a cake, how to make a pie, because a pie is similar to a cake, right? In some respects, right? So it's a little bit, we'll get different results based on semantic search versus keyword search. And then vectors. So vectors are the key thing here. Vectors allow us to uh, change text, audio, images into an array of numbers, basically, is what a vector is. A nice example that I like to use is if you go into a store and you're looking for something, maybe you're at the hardware store, you're looking for light bulbs, you ask a worker where to find those. They might say aisle 30, bay 15. That is a 2D vector. And so it's a way to easily find things. And usually you'll see that things are closely, they're together in the store, right? So you don't have light bulbs all around the store. They're all right there in the same spot, so easy to find. And so that's one way to explain vectors I like to use. Real world example. There's different ways to search vectors. So vectors are in a in-dimensional space, where in represents the number of vectors in that array. So in the store example, that was a 2D vector where n equals 2. There's different ways to search. There's a Euclidean, there's cosine, and we can, we're not going to go into depth into the types of vector search, but that's what we're going to implement today is vector search. And what we're going to do is we are going to use an application here. So again, if you use the link in the description, you want to follow along, you can actually just git clone this repo, and it is a starter. So let me just tab over to VS Code, and I have this repo already cloned, and it's right here. And let's just kind of go over it. This is a Next.js application. It is based on the Next LangChain starter. So it already had a bunch of stuff already in it for me. So we've got LangChain. We're using LangChain's MongoDB integration as well. So we have a native integration with LangChain. OpenAI, we're using the Versa AI SDK. MongoDB, Next, of course, React, all of the other things, and TypeScript. So let's go ahead and the first step that we have to do is, I'm glad I had everything hidden there. Let's go to the example here. So you're going to need an OpenAI API key. Now this is not tied to OpenAI. You can change this out. You can use different models, different providers. But in this example, we're going to use OpenAI. So you would first need to put in your OpenAI API key and MongoDB Atlas URI or connection string. So let me show you where to get that. If I go back over to my Atlas cluster. So in MongoDB Atlas, I have a database or a cluster set up here, and we need to connect to this. So let's go ahead and go to connect here. And I'm going to grab my connection string, which is right here. So let's copy that. Now I've already set this up. During the setup process, you have to set up database access and network access. By default, MongoDB Atlas is completely locked down. So you have to add your IP address to the access list and set up a username and password. So I've got all of that set up already. Let's go back over to VS Code. And actually, let me just stop sharing for a second here. And I'm going to put in my connection string into my environment variables file and be right back. All right, save that and close it. And then, cool. So now we got our environment variable set up. And again, this is based on that Next.js LangChain example starter. So without making any other modifications to this, let's just go ahead and test it. So open up the terminal, npm run dev, and let's go to localhost 3000. So I should have that up over here. Let's go to, yeah, here it is. So let's just do a refresh to make sure. And the only thing that you'll see at the bottom is just a little text box where you can ask a question. This is basically ChatGPT. So let's say, what is MongoDB? Pretty quick. We've got MongoDB is a popular open source NoSQL database, etc. So sounds pretty good. This is a standard answer that you would get from ChatGPT. Now let's enable this chatbot to answer questions based off of our custom information. So that is where retrieval augmented generation comes in. Let's go back over to VS Code, and I'll just leave that running. Now for this workshop, we have some assets in here, and I've actually used ChatGPT to create some fake documentation for a fake JavaScript library called fancywidget.js. So a bunch of fake documents. We've got a README, quick start, installation, changelog, API reference, usage, all of the standard things that you would find in an open source JavaScript library package. So obviously ChatGPT or none of the LLMs know anything about this fancy widget.js. So we're going to give it this custom information and ask it to answer questions based off of this. So the first thing that we need to do in order to allow it to use vector search to answer questions based off of this is we need to create embeddings for all of this. We need to vectorize all of these documents. Now, anything can be turned into embeddings, just about. Text could be markdown files, PDF, Excel spreadsheets, anything. You can also do audio files, video files, images, etc. For this example, we're going to create embeddings from these markdown files. So to do that, I got a couple of questions. Let me just look over at the chat real quick. To get support on this, if it fails, could I stay in the free Atlas plans or requires enterprise? Let's show that. So to get support, if anything fails, can you stay on the free Atlas plans? So for the free Atlas plans, there's no built-in support per se, as in if something is broken on our side, it will be fixed. But if you need support as help building things or yeah, or if you have issues on your side, then of course we have free community support. But the paid plans do or enterprise plans do include some extra help there. But as far as Atlas, the free plan itself working properly, you would definitely receive support if something is not working properly. And then can database entries be from Atlas? Yes. Yes, you can. If what you're asking is, can the entries come from Atlas or from it? They can come from any source, actually. So this could be here's you're adding to this. So the use case is to learn to understand certain user data and offer recommendations based on that. Answer questions. Yes, exactly. So you can create embeddings from any text field, any field within MongoDB Atlas. There are ways to automate that as well. What we're doing here today is very manual, but all of this can be set up to be automated based on triggers would be a good example. So within Atlas, there are triggers that you can set up. So if a new entry comes into your database, you can then run a trigger that then creates embeddings for that field, whatever that might be. And then that can be added into your embeddings, and you can do vector search or whatever your use case is. So I think, yeah, love triggers. Yes, exactly. That can all be set up. So again, this is all very manual today, but kind of gives you an idea of what's possible. So what we're going to do is there is a file in here already, and let's just go over this. So this is let's see, under 40 lines of code, where it's going to create embeddings from our custom markdown files. So we're importing file system promises from Node, and recursive character text splitter from LangChain, and OpenAI embeddings, MongoDB Atlas vector search, the Mongo client, and .env. So fairly standard stuff. We'll explain some of these things as we go. This first part here is we're just connecting to MongoDB. So we're using our connection string here, telling it what the database name and the collection name is, and then we're just setting up our actual collection here. The next thing is we're going to get those fake documents from our workshop assets directory, and then get the file names from each of those files in that directory. Just console log the file names and then loop through each file. So for each file, we're going to read that file and then console log that we're about to vectorize that file. So the first part is we're going to split the file. So a markdown file or any file could be really long, and you don't want to create an embedding off of that entire document. So we need to split the documents into what we call chunks. So there's a whole live stream that we could do just on chunking strategies. So here we have the chunk size set to 50, or 500 and overlap of 50. There is no one size fits all. These are numbers that you kind of have to play around with. Too large of a chunk, then you'll have extra overhead searching through those large chunks. Too small of a chunk, you won't have enough context. So there's a fine line there. Now we're telling it from language, we're telling it that these are markdown files. So LangChain, the reason why we're using LangChain is because it makes things so much easier. We don't have to manually do this. LangChain knows what a markdown file is, and it knows that a markdown file has hierarchy built into it. It knows that it has headings and different sections, and it will create chunks based off of those sections first off, and it'll be sure not to split sections like in the middle of a heading or something like that. So you'll have relevant chunks split from each of the markdown files. So we're going to await those documents, and then we're going to send those into MongoDB Atlas vector search, which again is a LangChain method, LangChain embed method from LangChain. So we're putting that output here from the splitter. We're giving it the output. Then we're creating the OpenAI embeddings and saving all of that into our collection. We're telling it what the index name will be, the text key, and the embedding key. So this is the text key is the field name where the unaltered text chunk, the plain text, will be saved, and the embedding key is where the vector embedding will be saved. So text field and embedding field Text is the plain text, and embedding is the array of numbers, basically. Console log that we're done and close connection. So pretty simple Node script here. So we are using Next.js. This specifically is a Node script, and we would have this script run on build for our Next.js application. We're going to run it manually today, but normally I would just have it run on build. Let's see, there's some more questions. Will there be a recording available of this? Of course. So this is being live streamed on YouTube and LinkedIn. Recordings will be immediately available as soon as we're done. They'll stay on YouTube and LinkedIn. Can you elaborate? Let me pull this one up. Can you elaborate just a little bit on chunk size and tell if there are some common practices about it? So again, it depends on your use case and what type of documents you are embedding. So if they're super long documents, generally you want to make sure that you have enough context within each chunk. So however your documents are broken down between headings or sections or whatnot, think about a logical chunk size that would encapsulate those sections and keep paragraphs together, so that you're not splitting sentences into or paragraphs into, making sure that there is a strategy to keep as much context within each chunk as possible, but also keeping each chunk as small as possible, so that there's not as much overhead when searching through those chunks. Again, a whole live stream can be done on just chunking strategy, and it's dependent on the type of documents or images or whatever the case might be that you're embedding, or well, chunking is specifically for documents. So depends on what type of documents you're processing there. So let's go ahead and run this. Let's go over to, I think in the package we have an embed script. So the embed script just runs node embed. So let's go ahead and run that. I'll just open up a new console here, a new terminal, and then let's do npm run embed, and it's vectorizing each of those documents, and we're done. Pretty quick. Let's go over to Atlas and see what it did. So let's go back over to my Atlas cluster here. So if I go to browse collections, we should now see, we see a docs database and an embeddings collection. And then within the embeddings collection, we have all of our different chunks. So we have an object ID or an underscore ID here, which comes with each of these. We have our text field, which is the plain text chunk. Our embedding is an array of 1,536 numbers. So these are our vectors. This is the actual embedding. It's just an array of numbers. And then we have some extra metadata. So a couple of objects here, nested document, where it's telling us which lines from the document that this chunk came from. So extra metadata there along with that. So nice. So we have all of our embeddings now. So we used OpenAI to create these embeddings, and we saved them in MongoDB Atlas. So the next thing that we need to do is set up vector search. So for that, we'll need an index. So let's go over to Atlas search, and we need to set up a search index. So we'll create a search index. This is going to be a vector search index, and we'll use the JSON editor there. Next. So our index name is going to be vector underscore index. We'll just leave that at the default. We need to tell it which collection to create this index on, and then identify the fields here. So the type, this is a vector search, so that's going to be vector. The path, so here it's looking for where are those embeddings? Where are those vectors? And for that, we used the name embedding. So that is the field where the embeddings are. How many dimensions? So we used OpenAI the Ada 02 model. So that uses 1,536 dimensions, depending on, there's many different models out there. So whichever model you use, you would put the number of dimensions that model uses here. And then the similarity, the type of search that we're going to use. And there's different types. For this, we're going to use cosine. There's Euclidean, dot matrix. I'm not going to go through the differences there, but there's different types of similarity searches that can be done depending on your use case. And so let's just go ahead and hit next and save that, create that search index. So now that we have the search index set up, we can now use vector search to find similar documents. So let's go back to VS Code. So let's go ahead and look at our app. So we have a standard chat route that came with this Next.js LangChain starter. So we already ran it to make sure it works, and this is basically the brains behind this example app. So this uses LangChain, and then in our post function here, we have our request, which brings in the user's prompt, the user's question, their message. So messages, this is actually a queue of messages. So it's an array of messages. We're using LangChain stream, setting up the LLM here, and then calling the LLM, splitting the human message from the AI message, and then streaming the response back. So I haven't changed anything here. This is the default example that came with this starter application. So what we're going to do is we're going to modify this. What we need to do is intercept the user's message, send that over to MongoDB to do the vector search, add extra context to their question, and then send that on to the LLM. So basically what we're going to do is right here, we're going to inject or intercept and inject some extra information. To do that, I'm going to create a new route. So we have API chat route. So I'm going to create a new route called vector search, and then route.ts. So now we have a chat route and a vector search route. So let's go ahead and let's see. I've got this code because I'm not going to type it all out by hand. Let's go ahead and I will copy this and let's go over this. So the vector search route, we are going to use OpenAI embeddings, the MongoDB client, and then MongoDB Atlas vector search from LangChain. So in this API route, we are going to receive the user's question and set up our MongoDB collection, just like we did in the embeddings script that we looked at earlier. So we're going to set up our collection here, connect to it, and then set up our database configuration, tell it which collection. Remember, we set up our vector index. We called it vector_index. That was the default name, and so we just stuck with that. We're going to tell it where the text, the plain text is. We're going to tell it where the embeddings are, and then send that database config down here to MongoDB Atlas vector search. So we're setting up our vector store. We are creating embeddings and giving it that configuration. Now, why are we creating embeddings here? This is going to be used for the user's question. So the user's question comes in plain text. All of our documents have embeddings as well. So in order to use vector search, we need the user's plain text question to also be in that virtual space as our vectors for our documentation. So we vectorize the user's question, we put it into that vector space, and we use vector search to find the most similar chunks, and then we return the plain text of those most similar chunks. All right, so this is our actual retriever here where we're calling the vector store. We're using something called maximal marginal reference. There's different types of searches that can be done here. And in this one, we are fetching the 20 most closely related chunks, and we're returning the lambda of 0.1, basically 10%. So we'll return two of the most similar chunks in order to answer the user's question. These are, again, there's no one size that fits the bill every time. So these are numbers that you kind of have to play around with. Again, there's different search types as well. So we are retrieving those chunks from MongoDB using MongoDB Atlas vector search, and then we will return those text chunks back to from this endpoint. So we're going to call this endpoint from our chat route right here. So here we are going to insert some extra stuff. Let me find the code for that. So that is, here we go. So here we are getting the current message. So again, the messages here is an array of messages. So it's a message queue. So we're going to get the current message. So we're going to pop off the last message from this queue. And so we know that that is the current message that the last message that the user asked. We're going to send the current message to that route that we just set up and fetch the results from MongoDB Atlas Vector Search. So vector search, that is going to be the results that we get. Then we're going to set up this template. So this is kind of the magic portion of this, where there's a bit of prompt engineering that goes into this. So here in this template, we are saying you are a very enthusiastic, fancy widget representative who loves to help people. Given the following sections from the fancy widget documentation, answer the question using only that information. Output it in Markdown format. If you're unsure and the answer is not explicitly written in the documentation, say, sorry, I don't know how to help with that. Then we add the context. So we stringify the vector search results from MongoDB. So that text is going to be added here under context. And then the user's original question, the original prompt that they asked. And so all of this template here, then gets pushed back onto the messages queue. And then it continues on as normal, being sent to the LLM. So again, we have intercepted the user's last message, used vector search to find additional context within our custom information, added that additional context, and pushed that back onto the queue and sent it off to the LLM to answer the question. Any questions? Okay, I'm just checking the chat, making sure there's no other questions. And let's see if it works. So let's close this. I still have it running. I don't think that I need to reset anything. Let's just go over to the browser and let's see if it works. Let's go up to, all right, so I'm just going to refresh this. And so now if I say, what is fancy widget.js? And there we go. It's kind of running off the screen. Maybe there's some CSS issues here, maybe, but Fancy Widget is a modern, lightweight JavaScript library. And yeah, that looks good. Now, the cool thing about this, because we are using the Vercel AI SDK, we have that chat memory kind of in place. We can then ask additional questions, and it knows the context. So let's just say, how do I install it? Now, normally if you ask ChatGPT, how do I install it? It doesn't know what it is. But in this context, it remembers. And so to install Fancy Widget via NPM, and it's getting all of this from the documentation that we provided it. Now, if I ask it something that is out of context, let's say, remember at the very beginning, we tested this. We asked this chatbot, what is MongoDB? And it answered us correctly. Let's ask it that again. And this time it says, sorry, I don't know how to help with that. That is because that question, even though the LLM that we sent this question to knows the answer to this, we specifically, through our prompt engineering, told it not to answer any questions that are outside of the context that we gave it. So that is, again, part of that prompt engineering there. So everything's working. It's answering questions. If we go back to VS Code, in the workshop assets, there are some sample questions here. So we could say, what license does it use? Let's go back. Let's ask this question. What license does this library use? And it's open source license as MIT. Awesome. So let me go back over to the chat, see if there's any more other questions. let's show this. Okay, so there's no requirement to use Next, right? I could just use React. And is LangChain the optimal choice if we want to use MongoDB VectorDB? So, of course, Next.js is not required. You could use any framework. You could use no framework. You could use plain JavaScript. You could use other methods, like you could use Python, Fast API, FarmStack, all those different things. No requirements to use Next.js. This was just, in my opinion, I love Next.js, and in my opinion, it's just easy to get up and going, but no requirements there. LangChain is a very good framework to use and set up AI applications. We have partnered with LangChain. We also partner with Llama Index. So there is another library called llamaindex.ts. So it's TypeScript based, and that is another great option as well. And that is, I wanted to run through this quickly, show you how easy it is to get something basic like this set up and running, see how the back and forth actually happens. Again, there are a lot of things that you could do to automate this. We talked about triggers within MongoDB Atlas. If you are, let's say you have a store where people are submitting comments on your products, right? Reviews on your products. Every time a new review comes in, you could set up a trigger that takes that text, vectorizes it, creates a summary of all of the reviews. And you've probably seen that on Amazon. At the top of the reviews or comment section, you'll see like an AI summary. Here's what everyone is saying is good. Here's what everyone is saying is bad, etc. Like a little summary. So you can set all of that up on automation. You could do like sentiment analysis. There's tons. The sky's the limit. There's so many use cases here, but all of that is definitely possible. So again, let me get the link to this workshop. And if you want to go through this on your own, it is self-paced. Very good workshop. I'm going to put the link in the description or in the chat again. And that is, if I'm just going to give another minute for any other questions that might come in. But again, we do this every Thursday. Every Thursday, it's not always myself, but it's one of the developer advocates from the AI pod. We have different pods within our organization, and AI is one of the things that we're focusing on. So every Thursday, one of us will be on here live streaming. Sometimes you'll see some Python stuff, Python notebooks, JavaScript, a lot of different things, basically just building applications live. And hopefully you have some questions and we can answer your questions and help you out. So join us again next Thursday. And thank you all for joining us. All right. Have a great weekend.